Hi everybody, today we are going to talk about special right triangles. So there are two special right triangles we use in trigonometry. So they are called 30-60-90s and 45-45-90s. So these represent the three angles you see in a triangle. So you'll have a 30 degree, a 60 degree, and a 90 degree denoted by the little square. Or you might see something like this. So if you have a 90, and you know that these two sides are the same, that means that these two angles are the same, which means that both of them must equal 45. So when you see a triangle like this, all special right triangles will follow the same ratio between the sides. So the first thing we're going to talk about is how to mark up a special right triangle. So for a 30, 60, 90, the way that I go about it is I always find 30. I always start across from the 30, and then in my mind I say 1, 2, root 3. So across from the 30, that side length will be 1. Across from your 90, or your hypotenuse, will always be 2. And your last leg across from the 60 will always be root 3. So if your triangle is rotated, the numbers might be in different places, but 1 will always be across from 30. 2 will always be your hypotenuse, and root 3 will always be across from 60. So for a 45, 45, 90, like you see here, it's a little bit easier. Your two legs will always be 1 and 1, and your hypotenuse will always be root 2. So the way I remember it for 30, 60, 90 is I say 1, 2, root 3, and then for 45, 45, 90, I remember 1, 1, root 2. We just talked about here, this 1, 2, root 3, and this 1, 1, root 2. So if you know what the ratio of your special right triangles are, you can actually find the missing sides of a special right triangle with only one side given to you. So when we were using Pythagorean theorem with other right triangles, you had to know two of the sides to find the missing one. Here, you only need to know one side, and you can actually find the other two using our ratio. So here's how you do it. If you're given a picture of a special right triangle, you're going to sketch a matching picture, so either a 30, 60, 90 or a 45, 45, 90, and you're going to try to make it look exactly like the triangle you're given, except we're going to use the labels. So from there, we can see that the two triangles that we've drawn are going to be similar triangles because all of the angles are congruent. Well, if we have two similar triangles, we can create proportions between the corresponding sides to find your missing sides. So let's give this one a try. Here I see that we have a 45, 45, 90, so you have to recognize it as a special right triangle, and they ask us to solve for x. So I'm going to draw another special right triangle that looks just like it. So it has like the same orientation. So I know that if these are 45, I know that my legs are always going to be 1 and 1, and my hypotenuse is going to be root 2. So now I can see that I have two similar triangles because all of their angles are congruent. So now I can create a ratio. So what I recommend doing is finding the two matching sides that we know. So we know both of our hypotenuses. So we know that this is root 2 and this is 6. So that's going to be what we use to create our proportions. So we can say root 2 over 6 equals, and then we can say 1 over x. Now we only need to create one proportion because we see that these are actually going to be the same length. So we actually only need to solve once. But from here, all we need to do is cross multiply. X times the square root of 2 equals 6. And then I'm going to divide both sides by the square root of 2. And here's what we get. So now this technically could be our answer, but in a math class, we never want to leave a square root in our denominator. That's just not how we want to write our final answer. So we have to do this extra step, and this step is called rationalize. We need to rationalize our denominator. So what you're going to do when you see something like this is we're actually going to multiply by that number in the numerator and the denominator, and then we're going to simplify from there. So in our numerator, 6 times root 2 is just 6 root 2. In our denominator, square root of 2 times the square root of 2 is the square root of 4. And now we just have to simplify. We know that the square root of 4 is 2. And then I see that we can simplify these two numbers because they are both non-radicals. I cannot divide this into a square root, but I can divide these. So I know that 6 divided by 2 is 3. So my answer is going to be 3 times the square root of 2. And I know that that's going to be for both of those legs because they're both going to be the same length. All right, so now let's try a 30, 60, 90. So in this problem, they tell us that BC is 14, and they would like us to find AC, which is right here. So I'm going to fill in this missing angle as well. I know it's going to be a 30. So the first thing I'm going to do is draw a matching 30, 60, 90. So I know that the rule for marking this up is I start across from the 30, and that's 1. My hypotenuse is 2, and my last leg is root 3. 1, 2, root 3. Now I'm going to circle the corresponding sides that match. So I see that 2 and 14 match. So I can say 2 over 14 equals, and I'm going this side over this side, so I have to say root 3 over x. And before I cross multiply, I'm going to simplify. I'm going to divide both of those by 2. And then I'm going to cross multiply. X times 1 is x. 7 times the square root of 3 is just 7 times the square root of 3. And there we have it. Okay, let's try one more together. This time they tell us that AC is 8, and they would like us to find this value, BC. So same idea. I'm going to draw a matching special right triangle, but with our markings. So remember, it goes 1, 2, root 3. And then I'm going to circle the parts that we know. So here we know square root of 3 and 8 go together. So that's going to be our starting ratio. And since we're doing this side over this side, we say equals 2 over x. And now I can cross multiply. So we have x times the square root of 3 equals 16. And then from here, we're going to divide both sides by the square root of 3. And remember, at this point, we need to rationalize the denominator. So we need to multiply the numerator and the denominator by whatever you see in the denominator. And this process should make that square root disappear. So in our numerator, we have 16 times the square root of 3. Here we have the square root of 9, which we will simplify because we know that the square root of 9 is 3. And here I can't simplify these two numbers. Remember, I cannot divide 3 into square root of 3. You can't divide a square root and a normal number. So this is actually going to be our final answer. All right, so go ahead and pause the video and see if you can solve for x and y. Okay, so you can see here, I drew my own 45, 45, 90, and I marked it up. 1, 1, square root of 2. Here's the drawing from the picture. So I matched up my corresponding sides. I know that this length of 1 goes with the length of 3. So I said 1 over 3 equals 1 over x. And then I also said 1 over 3 equals square root of 2 over y. And then I cross multiplied for both, and you get x equals 3 and y equals 3 times the square root of 2. Okay, here's the last problem. go ahead and pause the video and try to find x and y here. Okay, so here is the picture from the problem. So I drew a 30, 60, 90 to match. Remember, the 1 is always across from the 30. So we have 1, 2, square root of 3. So the 1 goes with the 8, the 2 goes with y, and root 3 goes with x. So I say 1 over 8 equals 2 over y, and 1 over 8 equals root 3 over x. So you get y equals 16, and x equals 8 times the square root of 3. Okay, that is all for today. Thank you for watching.